Have you ever stopped to think about what it actually takes to run a massive e-commerce site? We're not just talking about a simple online store. We're talking about a platform like Flipkart, an engineering beast built to handle the unique and, frankly, impossible scale of the Indian market. This is a story about how you build a system in the middle of a perfect storm, a mobile-first hyper-growth world. Let's get into it.
All right, picture this. It's the launch of Flipkart's big billion-day sale. Millions of people are ready, thumbs hovering over their phones. The clock strikes, and boom, the traffic to your servers doesn't just double or triple, it explodes. We're talking 100 times the normal volume. And get this, that entire insane spike happens in a single second. It's a tidal wave of requests that would literally vaporize most platforms on the planet. That is the brutal, unforgiving scale we're dealing with here.
So that's the big question, right? How in the world do you architect a system that doesn't just crumble under that kind of pressure, but actually delivers a perfect, seamless experience to every single user? Well, the answer is a masterclass in building for chaos. Let's break down how they did it.
Okay, so let's start where every user does, the moment you open the app. To win in a market that moves this fast, Flipkart needed its storefront to be incredibly dynamic, almost like a chameleon, able to change its entire look and feel in the blink of an eye. So, think about the old, painful way of doing things. If you wanted to change a banner on the homepage, you'd have to code it, build a whole new version of the app, submit it to the App Store, and then just wait. You'd have to pray that people actually update it. Flipkart's approach just throws that whole model out the window. The server is the puppet master, telling the app exactly what to show, and it happens instantly.
And the magic behind this is a technology called Backend-Driven UI, or BDUI. The idea is brilliant. The app on your phone is basically just a dumb renderer. It has a library of components. You can think of them like digital Lego bricks. The server then sends a simple file, a blueprint, that says, okay, put the big banner brick here, a product carousel brick below it, and a buy now button brick over there. This gives the marketing teams the power to completely redesign the app whenever they want without a single app update.
But what happens when that app needs to get information from like 10 different places all at once? Making 10 separate network calls from a phone, maybe on a spotty connection, is a recipe for a slow, terrible experience. That's where the backend for front-end pattern, the BFF, comes in. The app makes just one simple request to its best friend. That BFF then does all the messy work. It goes out, talks to all the different backend services, gathers up all the info, and sends it back to the app in one clean, perfectly formatted package. It's a total game changer for performance.
Okay, so we've got a flexible storefront. Now let's dive into the heart of the battlefield, the flash sale. This is where things get really intense. Millions of people trying to buy just a few thousand items, all at the exact same time. So to understand the problem, you have to understand something called a race condition. Let's set the scene. There's exactly one iPhone left in stock. User A sees it, and of course, smashes that buy button. The system starts processing their request. But here's the problem. At the very same millisecond, user B sees that same iPhone and does the exact same thing. So who gets it? A poorly designed system might check the stock, see one for both users, and let them both proceed. Now you've sold the same phone twice, and you've got one happy customer and one who is absolutely furious. So how do you stop that from happening? The solution is just incredibly clever. Flipkart uses a super-fast in-memory database called Redis for this. But the real secret sauce is a tiny script that runs inside Redis. This script does two things: check the inventory and decrease the inventory as a single, unbreakable atomic operation. Because Redis only runs one of these scripts at a time, it's physically impossible for two people to get in at the same time. The first one in wins every single time. It's how they guarantee perfect accuracy at mind-boggling speeds.
Now, once your order is locked in, the system's job isn't done. But instead of trying to do everything at once, it just fires off a simple message, an order created event, onto a messaging system called Apache Kafka. From there, a bunch of other services are listening. One service sees the message and sends you an SMS. Another one starts a fraud check. Another calculates your loyalty points. The beauty of this is that they're all separate. So if the email server happens to be down, who cares? Your purchase is already safe and sound. The email will just get sent later. It's all about building a resilient system that doesn't have a single point of failure.
So we've handled the chaos of the sale, but the user's journey is far from over. Let's look at how Flipkart connects that digital search on your phone to the very physical reality of getting a giant sofa delivered to your actual door. It starts with the search. You know that horrible feeling, right? You find the perfect item, you click on it, and sorry, this item is out of stock. It's so frustrating. Flipkart fights this with something called near real-time indexing. They have their main, massive search index, but they also have a tiny lightning-fast buffer in memory that just tracks the most recent changes. When you search, the system queries both, which means the stock and price information you see is fresh, down to the last few seconds.
Okay, now for the really hard part, the physical world. Delivering packages in India is a completely unique challenge called the last mile problem. You see, addresses aren't always neat streets and house numbers. They're often descriptive, like the yellow house behind the temple near the big water tank. How do you turn that into data a computer can understand?
Flipkart's incredible answer is the Logistics Promise Engine. This thing is like a crystal ball. Before you even think about adding an item to your cart, the LPE is running a massive calculation. It's analyzing the seller's location, warehouse capacity, truck and plane availability, holidays, and even the historical probability of a delay on a specific delivery route. It crunches all of that data just to give you one thing: a single, accurate delivery date. It's a massive prediction engine running constantly for every person browsing the site.
So, what's holding all of this up? The storefront, the insane sales, the complex logistics. Under it all is the data foundation. The database layer has to handle every single thing we've talked about without even breaking a sweat.
And Flipkart's database journey really tells the story of what it means to scale. They started where many do, with a single big MySQL database, and they very quickly hit a wall. So they moved to sharding, basically manually chopping up their data across many different databases. And it worked for a while, but it was incredibly complex and just painful to manage. Now they're moving to the future, distributed SQL, with a system called TDB.
So why make the change? Well, TDB gives them true elastic scalability. If they need more power for a big sale, they just add more machines to the cluster, and the system automatically balances the load. No more manual, painful resharding. And maybe most importantly, it lets them do maintenance and upgrades with zero downtime. That's something that was practically impossible with their old setup.
But here's the thing, it's not a one-size-fits-all world. Flipkart is a huge believer in polyglot persistence, which is a fancy way of saying use the right tool for the right job. You wouldn't use a hammer to turn a screw, right? Same idea. For their product catalog, where accuracy is everything, they use a database like HBase that gives them strong consistency. But for things like user activity logs, where you can't ever afford to lose a single click, they use something like Cassandra, which is built for extreme availability.
Okay, let's zoom all the way out. We've seen all the pieces, so if we were to put it all together into a final blueprint, what are the big lessons we can take away from this incredible system?
Well, first, they're smart about the cloud. They run their day-to-day operations on their own servers to save costs, but they can burst into the public cloud for those massive sales. Second, security is paramount. They use a zero-trust model, which means no service is trusted by default. Every single one has to prove its identity constantly. Third, as we saw with Kafka, their event-driven design is the key to resilience. And finally, everything is driven by data. Every decision, every feature is backed by numbers.
You know, at the end of the day, what you're looking at isn't just a random pile of cool technologies. Flipkart's architecture is a direct, strategic response to the world it grew up in, a world of shaky internet connections, massive spikes in traffic, and unique real-world challenges. Every single piece of this system was built to solve a specific, incredibly difficult problem. And that really leaves us with one final big question. This amazing system was built to solve the impossible problems of today. But as the next billion users come online, with new devices, new behaviors, new demands, what is the next impossible problem that architecture will have to solve? Something to think about.